Hands-on stuff.
All right, it's 2. You can start the lecture. Hi, everyone. Everyone, Alex is traveling today, so I'll be subbing in. I'm actually your guys' classmate in this class, but I'm also a PhD student of Alex's, and my research topic is closely aligned with today's lecture. So we'll be talking about design guidelines today. So kind of there are many opinions, there are many prescriptive rules on what visualization design should look like. Today, kind of will introduce 2 pretty broad rules that are important to keep in mind, and then we're going to go through many different examples of not rules, but at least considerations in design of visualizations. Kind of like rule 1 would be use your best visual channel available for the most important aspect of your data. So this kind of goes back to something Alex was talking about the last couple of lectures, where there is an empirical ranking of what channels are best perceived by the viewer, starting from kind of position and all the way down to like 3D volumes and colors. So using the best available channel would yield just like a better readable chart. So this would be the effectiveness principle. And then the second rule is more of an expressiveness principle of the visualization should show all of the data and only the data. So kind of try to not include too many extraneous things in your visualization. And we're going to talk a bit more about caveats to this. So there's one book recommendation on the topic. It's a book by Cole, Nussbaumer, and Knaflic, kind of talking about storytelling with data. And I believe there's a lecture on storytelling later in the semester, but this is a useful read. So Edward Tufty, many of you might have heard the name. He's a professor of computer science statistics at Yale. He is kind of one of the first people who talked in detail about design principles or design guidelines of visualizations. And he is one of those very opinionated people on visualization design. And his principles are kind of distilled to this. You want to show data variation, not design variation. You kind of have to be honest and faithful to the data in visualization. So he advocates for clear, detailed labeling and appropriate scales. And kind of the most important idea he distilled into this notion of the lie factor. So it's literally that the size of a graphic effect in the chart should be directly proportional to numerical quantities that underlie this effect, which kind of sounds very intuitive and like duh, but there are many violations of this factor. So let's jump into scales, which I think is kind of like one of the most directly relevant part of the visualization to this principle of the lie factor. So the lie factor could be like formulaically shown as the size of the effect shown in graphic divided by the the size of the effect in the data. So essentially, like magnitude of the mark in the chart should correspond to magnitude of the data. So kind of one chart that violates that would be this. Kind of the effect in the data is going from like 35% to 39.6. So that's roughly a factor of 1.14. But the effect in graphic is roughly a factor of 5. So we could kind of calculate this. The lie factor of this chart would be 4.38. It's not in and of itself like very necessarily illuminating the number, but kind of the point still stands. The magnitude of the change shown in graphic is much larger than the actual magnitude. So if we plotted the same chart with an axis that starts at 0, this would be kind of the same data, but it elicits a slightly different reaction, probably, especially if you quickly glance at it. Another thing that can go wrong with scales is this. So I believe this is a chart that shows kind of how much of like tax money is being used by like people of different ethnicities in Austria, I believe. So here, kind of the leftmost bar is Austrian, then it's unknown, then it's, I think, Turkey, Serbia, Syria. So here, obviously, like the creator of the chart. Well, first of all, does anyone spot what's wrong with this chart?
You can't see the top.
Right. So you can't really see the top of this chart. Weirdly, this is kind of the top of the chart as it is. But yeah, you can't see the top of the data. So you can see that like the number on the first bar is 100,000. The next number is 16,000. So it honestly kind of looks more like this, but still not quite. So here kind of, there was a choice made, and the choice is not very obviously faithful to the underlying data. Another kind of recently relevant example is coronavirus cases. Here, long ago, there were only 80,000 cases in different countries. But here, essentially, we don't see the axis, but it's the implicit axis is also truncated. And going from 80,000 to 81,000 roughly looks like going up 50%. This is an even more absurd example. Here, it's not that the scales aren't faithful to the data, the nothing is faithful to the data, right? Like we're just looking at completely randomly encoded values. Perhaps, right? So don't do that. So kind of all of these examples might lead you might have heard somewhere else that, oh, you just shouldn't start your scales at 0. That will solve every problem. And I think it is an important consideration. Oh, whoops. Interesting. Okay. I'll try to not touch anything. It is an important consideration. Kind of this chart shows we're actually looking at the same data in both lines, but the scales are different. So the orange line is kind of plotted on a scale that starts at 0, or it's the blue one does not start at 0. And I would argue that both are valid depending on what you want to show, right? Like the blue line shows much more immediate detail of kind of the trajectory of, say, like median household income, for instance, on this chart, whereas the line that on the axis that starts at 0 kind of generally just looks flat. So our old friend Edward Tufty says that you should use a baseline that shows the data, not the 0 point. So it should always be meaningful with regards to your data. For example, like a very basic example is how we talked about how there are different quantitative scales, some where 0 is meaningful and some where 0 isn't meaningful. So for example, with temperatures, it wouldn't necessarily like be incredibly necessary to have 0 on the axis because it's not necessarily meaningful. Whereas 0 is meaningful still, like, is it meaningful for your data? So there's this video by Vox that I hope my sound will be okay. I
Make a lot of charts at most. I know.
my sound will be okay.
And of course, charts have axes. Pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing to complain. You see, there's a really famous book called How to Lie with Statistics. It's a discussion of how you can create a misleading chart. Of course, charts have axes. And pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing to complain. Really Fox News, for example, it's a total disaster. But the y-axis dogmatists take it way too far. The big problem with the people who lie with statistics is that they're lying to you. It's true that misleading charts are one way to lie, but the English language is also a tool that can be used for lying, and that doesn't mean we should never speak English. Sometimes you need to fiddle with the y-axis to tell a story properly. So, for example, right now, the share of American adults who have a job has fallen to a generation-long low. It's a really big deal. But if you chart this data with the y-axis at 0, you can't see the change at all. Narrowing the range to dramatize what we're talking about isn't lying with statistics. It's emphasizing what's relevant. The way Edward Tufty puts it is you need to use a baseline that shows the data, not the 0 point. And after all, 0 is just a number like any other. Sometimes to make sense of the data, you need to be able to show numbers that go below 0. Halting at 0 in those cases doesn't make any sense, but extending every chart way below 0 would be crazy too. And of course, where 0 even is depends on the units you're using. If you do a chart of a person's temperature in Fahrenheit, you're likely to miss the fever if you zoomed all the way out to 0. If you redo it as a Celsius chart, it's not quite as bad. But if you switch to Kelvin and extend everything to absolute 0, then your charts become useless. When people are really lying with charts, the main thing they're normally doing wrong is leaving out the context, not leaving out the 0. Go back to that Fox News chart. You'd never know from this chart that the top marginal rate was 39.6% back in the Clinton administration, or then the Reagan administration, it was 50%, or that back when Eisenhower was president, it was 91%. The missing 0 was really the last of that chart's problems. What they left out was the entire history of taxes in the United States. So just remember, y-axes don't lie to people. People do.
Right. Yes, so like this video said, like visualizations can be used to lie, but it kind of depends on the framing and what's being shown. But the very baseline is be faithful to the data. That will get you a long way. But like in their example of the tax cuts, kind of the amount of data you show also kind of matters in terms of what you see in the chart. So there are many ways you can like wrangle world average temperature to look not, supporting global warming. But depending on like how far you go and what value you actually show, you can see a general trend line. So another thing that can go wrong with scales is, can you tell me what's wrong here? Yes. Right. Right. So we have like 3D charts going on, but also what about the values on the x-axis? Right. So they are ordered in terms of like magnitude, and I'm not actually sure why these 6 numbers or but we kind of have this implicit mental model of when we look at temporal data that we want it to go from start to end, from left to right, and this is kind of violating our assumption that sort of time moves from left to right, or at least in one direction. So this might kind of show the trend of temperature going up, and it is, but sort of not strictly in the way that the data is showing. kind of this is a sort of another similar example. Or the ordering is right, but these are also kind of 4 random quarters we're looking at. They're not spaced as evenly as sort of the data points would imply that they're spaced. So even here, even though they're ordered correctly, they're still not arranged in the graph as they're arranged in time, right? There's a sort of a larger gap between some of them. Another Fox, another COVID chart. Does anyone see the issue here? Right, so kind of also a similar issue, like a step in the y-axis is not consistent. We go from 30 to 60, but then from 90 to 100, then from 190 to 240. So if it doesn't distort data as dramatically, but if we plotted on like a valid axis, the shape would look slightly different. Another consideration in scales is, do you show a linear scale or do you show a logarithmic scale? Log scale, nothing is wrong fundamentally about log scales, as long as the underlying data and the insight you want people to gather from the visualization warrants it. So we've seen a lot of different exponential and log scale charts in the past couple of years with COVID. And here's kind of an example of the same chart just being plotted at different axes. Does anyone like one or the other better? And if so, why? Okay.
More easier to separate from the line.
Right.
Whereas on the right, they're just rounding each other's.
Yeah, absolutely. Right. So it kind of depends on, yes.
Yeah, I think that like, it depends on like, what's the kind of like story you want to tell, because if you want to like show that New York has like significantly more than everybody else, like you want to show the one on the right, but like, if you just want to like present more like information, I think the one on the left, like you can get more information.
For sure. Yeah, so you guys are right. Yeah, Chris, do you have a thought?
I was just gonna say, yeah, I agree. I think there's more information on the left if you know what a logarithm is, because I don't think it's a really fair or reasonable perspective of every human on Earth.
Exactly. Yeah. It's a great point that whereas on the left you do see so much more variation, you can order things more appropriately, but even if someone knows what a logarithm is and you kind of show the axis appropriately, I mean, you can bet that at least someone will quickly glance at a chart and not really notice that and kind of try to make linear comparisons to values when they're not valid. So kind of be explicit about an unconventional axis and also kind of think about whether it's appropriate. Since we're on the topic of all these COVID curves, normalization is another important consideration. So you always want to compare apples to apples, right? You don't want to compare values that are not necessarily comparable, again, depending on the insight. So if we go back to like a COVID chart here, this chart shows cumulative cases in different countries not normalized by population, right? So even though there are many insights you can get from this chart, excuse me, they're all very much skewed by the fact that like the United States is a very large country, India is a very large country. And if you normalize cases by population, which I would argue, at least in this case, is more appropriate, then you kind of see a slightly different picture of like, oh, maybe South Africa disproportionately has like more cases than some larger countries, etc. You can spot how India dropped down way low in this chart compared to the previous one. And Alex has a very interesting blog post on sort of dashboards and COVID data visualization that I would encourage you guys to look at. Okay, so shifting gears a little bit, showing distributions, there are many kind of design considerations here. So let's, for example, look at this chart. So the height of the bar encodes the mean of a distribution. So we're not showing the distribution itself, we're kind of just showing the mean of it. Let's do show of hands. Which value plotted as a point on the chart is more likely to belong to this distribution? Who says A? Okay. I have 2. Who says B? I have many. So obviously, trick question. They are equally likely to belong to this distribution. And obviously you might have realized that they are kind of equidistant from the mean of the distribution. But we know that people are biased by when shown the area, right? It's called the within the area bias. We can plot the data faithfully by kind of showing the point equidistant from the mean, but we perceive it wrongly. So if we just showed the mean of the distribution by like a line, then you will not be ever like confused to think that, oh, maybe things within the bar are more meaningful than things outside of the bar. This has been studied scientifically. And for example, given like 4 experimental conditions shown to people, chart on the right kind of shows you the mean bias. And you can see how, like, for example, the leftmost chart, similar to the one that we looked at, elicits like the highest bias in participants in one direction, whereas the rightmost chart, D, kind of is pretty neutral. Like you can see that the interval only bias is pretty centered around 0. So people don't really feel like point A or B is more likely to be within the distribution. So this is kind of 2 examples of what I'm talking about. If you're showing like statistics, which is just mean and kind of standard deviation of your distribution, showing it as a bar would very likely confuse people into thinking that kind of points within the bar are more likely to belong to the distribution than points outside of the bar, even though it's could be like symmetric. So violent plots are probably usually a more accurate representation of a distribution. A similar thing is happening with people estimating trend lines in, for example, like scatter plots. So given random points, we can kind of trace this imaginary like regression line through them. But here also research shows that if we for some reason plot these points as like an area bar, then people are also kind of more likely to think that points that belong inside of the area are more likely to be in the distribution. So kind of you can see the sign error of participants was much larger in magnitude for area charts. So we're worse at estimating accurately trends given an area chart. So this is about kind of the within the bar, within the area bias. So pie charts deserve their own section of this class. There are many opinions on pie charts. So pie charts are not universally bad at all. They are very good at showing part of whole relationships. So you can look at this chart and kind of get a lot out of it. You can immediately see that Chrome is the largest browser in 2018. Chrome and Safari are 2 of like the largest browsers in 2018. But there are ways we can improve many pie charts, I would argue. So for example, it's really hard to figure out what the tiniest segments of it are. Like I am actually not sure if I can distinguish other from Opera, especially given how tiny it is. So kind of be mindful of that, maybe bucket a lot of smaller things into other, but also be mindful of the fact that other can end up being a pretty large wedge that can also confuse people. And yeah, this also kind of goes back to this idea that here in a pie chart, our only channel of distinguishing between categories is color, and there's a limit to how many colors we can easily distinguish. But that was a tweakable pie chart. There are some pie charts that are just plainly wrong. Here, yeah, as I talked about, it's pretty good at showing part of whole relationships, but there has to be some kind of a whole that you split up into parts, not just obviously values that you try to sum up to a whole that don't. This is especially bad because what this is actually showing is not the percentage of Americans who have tried marijuana, but of people who have tried marijuana who supports legalizing marijuana, I believe, over the years. So kind of, this is in many ways pretty bad encoding of this particular data. Kind of similarly here, even though we do ask, it is in theory more appropriate, like we do ask people one question, they list their concerns. If you're allowed to list more concerns, as I feel like this data has been suggesting, they still don't sum up to 100. So it's kind of meaningless to divide a pie of more than 100. Some people are very opinionated against pie charts. And for example, this blog post is pretty interesting, lists out potential redesigns of pie charts to make them kind of easier to read and more faithful to the data. And one idea is to simplify all the colors because there are many and we can distinguish between them. But at that point, why just not make a bar chart? And that is kind of the answer to, I would argue, many cases, probably not all, but it is much easier to sort of rank them, proportionally compare them, and read off individual values from the chart on the right than the pie chart on the left. But perhaps the chart on the left is kind of more effective at showing one share of the pie. And kind of this is an artificial experiment, but if you ever end up in the situation where you have three kind of data points over time, and I would argue it's really hard to distinguish which slices of the pie are larger in any of these charts. The underlying data actually looks like this, and you can kind of see how, like, immediately from a bar chart you see so much more information, so much more detail. Some good uses of pie charts is showing proportions of pyramids or pies. So here's kind of like a case study of, like, let's say you have this type of data and you first visualize it with pie charts. What can we do instead? So here kind of you have survey data before and after some kind of summer learning program in kids, their attitude towards doing science. And you can spot trends in this data, right? So like the green okay part went all the way down, the bluish 19% went all the way to 38. So kids generally feel more excited about science. But one thing you can do is you can just like list out the number, right? So if that's what you mostly care about, that, oh, people's attitude towards science increased, then you can just literally state that as in a sentence and show a number. If you insist on showing more detail, so sort of here a bar chart, or I would argue, is also more immediately appropriate to the data. If proportions matter, an alternative to a pie chart is a stacked horizontal bar graph, which does not solve all of the pie charts problems, but I would argue many of them. Still, you have to be mindful of the number of categories you have, and if you distinguish with color, then also the number of colors you have, and if it's a tiny sliver, labels become complicated. But here, it's much easier to make kind of direct proportional comparisons. Kind of another alternative is this idea of slope graph, where you kind of show the pre-value on the left, and then you stretch a line segment to a value on the right, which is a pretty cool way of showing kind of changes. Here's another example of a chart from, I think, a New Zealand magazine showing kind of results of a survey over years of what people think the most important issue in New Zealand is today. And for some reason, they thought it would be a good idea to overlap different answers on the survey. And more importantly, what they did here is they encoded the quantity by diameter, not by area. And we talk about how people are not as good, not nearly as good at comparing areas as they are at comparing like positions, for example. But here, the diameter, the area scales like not linearly proportionally to the diameter, right? There's like a pi in there somewhere and a square. So in this example, it would be much more faithful to data to kind of scale the circles by diameter, but by area, not diameter. For example, like look at these two data points and just how dramatically larger diameter looks than area. But I'd still not argue for using this encoding in the first place, because if you are showing people's attitudes towards like two different issues over time, why not just use a line chart in a way? Here we kind of can clearly separate. It's not for some reason apparent that like race relations is a subset of crime and violence. There are two distinct things. But this is kind of related to this whole idea of like, well, no matter how much I think the bottom chart is more appropriate than top one, it is like much more boring. And kind of like in one of the first lectures, we did the design critique of Bill Gates's favorite chart. And one discussion point that came up was, well, it's much flashier. Like if you scroll through a website and you see that instead of some kind of a line chart, you're probably much more likely to pause and think about it. There's obviously a limit to that, because like sometimes you just embellish things in a way that just make it so much more confusing. For example, here, this 3D chart, if we turn into 1D, or sorry, 2D, it's much more easy to read off the values. Like if I can go back, it's not immediately apparent to me that the rightmost bar is at 700, but it is. So there's this idea of chart junk, and maybe we should avoid this word, but it's in the slides, so I'll use it. So kind of this idea of like, well, you have some extraneous elements to the chart that are not important. Why not kind of get rid of them to make things less confusing? So here in this bar chart, you can remove the grid lines. You can remove the shading because obviously bars are in the chart and everything else isn't. You honestly don't need the rest of the box. You just need kind of the y-axis, the x-axis. Well, maybe you don't even need the tick lines or the axes themselves. You can embed things into the bars to see them. And maybe you don't need a line at the bottom symbolizing the y-axis because it's pretty aligned. But kind of where did that leave us? It's pretty easy to read this chart, but it's very minimal. So there's this trade-off between embellishments and non-embellishments. This might be an extreme example, but I'd be curious how many people prefer the chart on the left and why? Can show hands or just yell out. Why?
It's fun to look at.
Right.
Like if you see the Moulin Rouge, you're like, oh yeah, absolutely this. But the other one looks like it belongs in like a scholarly paper.
Right.
You kind of glaze over that one, like, okay, that's nice. This one's going, oh, it's a cabaret girl whose leg happens to be the chart. That's cute.
Exactly. Any other, does someone prefer the chart on the right and have strong opinions about that? It's fine. It's visualization design. Everyone has strong opinions. Yeah, go ahead.
I was gonna say the one on the right, it conveys data without needless, like, I guess for lack of a better term, needless sexualization.
For sure. I'm glad someone brought that up. Another example is sort of this, and it's like translation to the boring scholarly world. So people actually did research on what's better, quote unquote, and the results are pretty cool. So at least in the charts that they've tested, the ones I showed you among others, they found that participants shown this chart didn't show any difference in like the accuracy of their interpretations. Like people pretty accurately read off all the values from embellished charts, not embellished charts. they didn't find any difference in like accuracy of recall of like how well people memorize the data or the message of the chart in like 5 minutes after people have seen the chart. But long term, like 2-3 weeks later, people who were shown the embellished charts remember them much better. And you can kind of see why. Like you can associate these bars with teeth, you can associate the line chart with like, I don't know, the shape of a leg. So they kind of make these better connections to people's memories. And yeah, more attractive, most enjoyed, easiest, and fastest to remember. So this is kind of a trade-off, right? Because you want to be true to data, you want to be pretty impartial, but sometimes there is value. There is value to embellished charts. Kind of like listing out pros and cons again. Like there are pros in persuasion, memorability, and engagement, but you might present a bias analysis. Another important thought is I'm not sure this was measured empirically, but at least logically it makes sense to me that some people might not be as willing to trust those like embellished charts as much as scientific looking charts. So it's also a trade-off to keep in mind. Oh, and obviously effort, like some of them are their works of art. Alignment of the chart. So here, this is a comparison of how politicians lie, and kind of like 2 ways you can arrange these bars is one, just like aligned on the left or right, but you can also align them around this sort of like 0 point of truth versus lie. And I'd argue you can kind of more obviously see at least some aspects, some insights from the chart on the right. 3D. So we've looked at this chart on like psychophysical power law that shows that people are really good at perceiving like changes in length or mapping changes in length to kind of the value. But the coefficient for like depth and area is much lower. So we're pretty bad at judging depth. With depth and volume also comes the issue of like perspective distortion. Like I said, it wasn't obvious to me that that bar hit kind of the top of the axis, but it actually did. Color, once you get 3D, like the way to show 3D on a 2D display is obviously perspective, but also like lighting and shading. So you're kind of stealing channels of sort of visual communicative data from yourself by having to kind of shade the bar many different colors when it symbolizes one single value given 3D. Tilted text is also harder to read. So I think like generally there were trade-offs and caveats and most things we talked about, but I think the consensus on 3D charts is just like don't. There is value to embellishment and like memorability and engagement, but I think it's pretty low value here. Like what is going on? I'm not sure. Thankfully, like most 3D design alternatives have like 3D designs have pretty straightforward 2D design alternatives. Like it's not like we gained anything from many of those charts on the previous slide. Perhaps this one, but like even though I would argue that the improved charts are still pretty hard to read, they are readable compared to like the left one where there's at least one bar that I'm sure we just like can't see. And yeah, there's this idea of how like this is from a paper published in 2002 in like the early wild days of visualization. It was more of like how much data can we cram into an image versus how much data we can read off from an image. And I think it's an important kind of thing to keep in mind. This was published as a novel visualization technique, but like 20 years later, I think we all agree that can't really read much from here. Right. Another consideration similar to 3D is about animation. And this chart, I think, is a pretty good example of the idea that we are better at seeing than at memorizing. Might be obvious, but I think that is a connection that's important to make to charts with animations. So let's let this guy play. So this is showing kind of distribution of fertility over time, like births per woman with the age at the x-axis. So I don't know about you guys, but I did not fully remember everything I just saw. There were some interesting trends, but I mostly forgot about most of them by the end of it. I'm sure if we like keep re-looping it, we'll like remember all of them, but it's pretty hard. But it is an interesting question of like, this in theory is a pretty good channel of showing this type of data, right? We're showing everything, we're showing it over time. We have so much detail in the distributions. So what could we do differently? So one idea is just to show every frame separately and just have however many 8x8 visualizations to look at. Does anyone like this approach? Does anyone dislike this approach? So why so? What's not great? What do you dislike about it? Right. But even if you like zoom in, it's just a lot, I would argue. Like it's so many charts. And it might not be like entirely obvious because the changes might be slow, so it's hard to kind of trace the trajectory of things. Yeah, a lot of charts. Do we need all of them? Maybe we need just some of them. Whoa.
I think it's not insensitive.
Really?
Just like.
Well, I guess we see. So one idea is to kind of, oh, thank you. Limit the number of frames, right? You can like skip over some frames. This is better, I would argue, but still probably like many to look at. But at this point, you can like stop and ask yourself, like, what is exactly it is that you're trying to show here? So maybe you could split it up into a couple of different charts that kind of give a bigger picture, or just one if there's a specific thing you want your audience to take away, right? So you can just plot total fertility rate over time. You can plot average age when giving birth in one chart. And here they're kind of probably like two different insights we can gain, and they are, I would argue, much more obvious from this chart. Like I personally saw some interesting trends in the animation, but I had to like sit down and think about it to see what exactly it was. But here it's all there. But this idea of like showing many values or distributions changing over time, it is an interesting visualization design problem, and there are kind of some other alternatives that people have come up with. So for example, like on the top, you just see 3 scatter plots, and the idea of this is like, well, how do we distill this into like one chart? So bottom left, we kind of show superposition. So you go from like a paler to a more vivid color for any given value over time, which is like essentially just encoding all 3 scatter plots in the same chart, just shaded slightly differently, which is a pretty good solution. I think you also run into the issue of like, you might have too many colors to distinguish from. The one on the right is a pretty ingenious solution, I thought, of kind of like showing the movement, kind of like imitating a tail of a comet or whatever. Here, I think it's like easier to observe the trajectory of how values change within a certain category. Okay. So now kind of we've gone through like a whirlwind tour of all like considerations of visualization design. And so you've taken all of them into account. So you created this like easy to read, memorable, beautiful chart that's faithful to the data, has like a life factor of one would be, yeah. So this chart is perfect, right? Well, probably, maybe not. But I wanted to talk about this idea of how up till now we had caveats for like, well, what is better for your purpose? But there are many examples where some charts were better, some charts were worse, some charts were good, some charts were bad. I would ask you questions like, what's wrong with this chart? Or like, why do you dislike it? But now I kind of want to talk about the link between visualization design and not the good or bad insights, but just different insights you can get out of them. So I would argue that many design choices in visualization shape our insights, even if we can read data off perfectly, right? Chart being faithful to the data is a necessary but not sufficient condition of having a good chart. So I thought we could play a little game. So I will show you some charts and you tell me what you see, what kind of like insights you can gain from the data. And kind of don't limit yourself just to the data that exists in the chart. You're allowed to like speculate, guess, use your knowledge if you have any like insider knowledge on the topic. Okay. So let's start with this one. So this is a chart from a CDC report on an outbreak of coronavirus in July 2021 in Barnstable County, Massachusetts. So we see in the month of July, kind of the number of cases. And if you can make out the legend, so the lighter blue shows the proportion of cases that were fully vaccinated. The darker blue shows the proportion of cases that were not fully vaccinated. Kind of, what do you see in this chart? Yep.
You could conclude, if you're wrong, you could conclude being vaccinated, but
Interesting. What makes you think that?
the area of fully vaccinated here is larger than the overall area.
Okay, cool. Does anyone see anything else? It could be anything. Yeah. Okay. What kind of what led you to this insight in the chart?
Because probably more cases when you don't have a mask.
Nice. Yep.
A high proportion of the population in this place are vaccinated.
Okay. What made you think that?
The area, right? There's more people that got infected with vaccinated, still vaccinated.
Right. So you also kind of like add your world knowledge context that, oh, if like vaccines make it less likely the vaccinated, if we still have many vaccinated people, it's likely that sort of
Yeah,
there are many, right? Yeah. Yeah. Right. Yeah.
A lot of people partied on July 4.
Exactly. Exactly. Here, like another way that you embed your like world knowledge into, oh, this is July 4th, this is America. Yeah, this is great. Any other thoughts? What else can we see from here? Yeah. Interesting. Yeah. Cherry pick to yeah. Any other insights? Cool. So one insight that we kind of hinted at that I will share with you is this chart was very popular on Twitter to support the idea that vaccinated people are super spreaders, which kind of is something we talked about, but like on the one hand, you had the idea of like, oh, maybe it's showing the opposite, right? That the underlying population is more vaccinated. So you're kind of like your personal knowledge, your personal biases come in, and these design choices, like for example, why exactly were the bars sort of like colored? Was that like meaningful for the insight? Well, it led to like a variety of different insight on the spectrum of like personal beliefs and personal knowledge. Cool. Continuing this topic, is let's look at this visualization. So this is a coronavirus dashboard from like the official Mexican government website. This is like a snapshot of beginning of the pandemic through like middle of 2021, excess mortality. What are your insights from here?
Kind of feels like there's a bit of redundancy coding.
Okay.
Like they have a negative value that you can see by the bit below the chart, and you have the peaks that are higher, but they're also more deeply colored.
Mhm.
And I almost argue that that's just not a necessary thing to view this chart, because you're already conveying a lot of them. I'm going to colors, but it doesn't really give me the perfect insights.
Mhm. Yeah, no, this is a good point. I think generally like people like excess or like redundant encoding, which kind of just like if you have two channels of showing the same value, it might be like more apparent what's going on than one. But I can totally see that, especially like you're the color choice of like red bad, blue less bad kind of also plays in, right? Which might be good or bad depending on what you're showing. Yeah.
I was a little bit confused with the data ended around the 20-week mark in 2021, because on one hand, it goes all the way to 32, but on the other hand, using real world context, well, how likely is it that zero for that whole time? So, is there more data or stuff that ends around the 20-week mark? I'm a little bit confused on that.
Right. So is it like a data validity issue, or are we looking at like a true phenomenon? Right.
Yeah.
Yeah, that's a great thought.
They just normalize the data scaling and no more excess or less excess. Everybody was just 0%.
Oh,
I'm not sure, but is that your expert knowledge? Oh, okay.
Obviously, you don't have data for them.
Okay.
They're just 0%.
But in theory, you could be the expert on the topic and maybe I would believe you. So yeah. Does anyone have any other insights on like the trajectory of, yeah.
Second winter was pretty rough.
Yeah, that's a great point. It kind of like jumps out at you immediately, right? That like there was a peak and it was pretty large. And it was like around the winter. Yeah.
So basically what it's saying in Spanish there is like is the excess of all every causes of death, the excess. So the excess with respect to what?
Mhm.
Right? Because what they're comparing that to. Right?
Right.
It's like the X, how many were dying compared to the prior week? What does exactly mean? It's not clear.
Right. So there's a lot of like methodology and stats probably that go into this that are not like immediately obvious from the chart unless you read the notes or whatever. Any other insights? Okay, so the conspiracy flavor of the month that this was used on Twitter on was to support the idea that ivermectin helped winter the storm in early 2021. So here this is interesting. We're kind of like also someone is embedding their knowledge, however true or not true it is, of like something happening and explaining like a phenomenon that we did see in the chart, right? The peak in the winter, and then it went down, and then God knows what happened to the data. So here's an insight that someone had from this, linking it to kind of their knowledge that there was some treat program with ivermectin and their belief that it is efficient.
So that's the thing they're assuming to their COVID, but the data doesn't say COVID only gets where.
That's also a great point. Yeah.
So like it looks like the conspiracy solution is making quite a fun thing to add clips on top of the graph. Is that like would that have made this better if they added clips that like would have appeared inflection points in the graph? Like the obvious question you asked when you look at the visualization, why did those peaks happen? Where did they come from? Where did they go? So is like the right thing to do at the context after or is it in the graph itself embedded with these text like textual clips and animations?
That's a great question. That is like literally what my next steps in research will be to figure out how to fix this. But yeah, I think the general idea is you you have this very neutral chart, and we'll talk about this a bit more in like a couple of minutes, but you have this very neutral chart that attempts to show data in an unbiased way, but that just leaves you a blank canvas to inject whatever biases you have into the data, right? So if something is unexplained, and I would not argue that there is an explanation, there is a complete explanation to this, right? Like COVID is such a complex situation, like we don't know what happened there. There's a mutation, there's vaccinations, there's some successful treatments, just seasonality. But like having none of them, interestingly, like does leave it as a blank canvas for someone to, you know, underscore an aspect of their choice. Okay, last one. We kind of know where things are going now, right? So might have biased you already, but this is our world in data. We're looking at COVID cases in Uruguay, also around the same time period. What do we see? Right. What does it tell you? What does it speak to you?
This is not the cumulative number of cases, but the number of new cases confirmed per day. However, stuff doesn't feel that way, to be honest. This shouldn't be possible.
Oh, so because it's so extreme?
Yeah.
Okay. Yeah, so I think the data is given like difficulties in methodology and testing. I think it generally makes sense because there's like a dip, right? So we didn't like negate any cases. But yeah, that's a great point. Like it's such it is an extreme rise in cases, right? So
it's very smooth. It's a 7-day rolling average.
Yeah. Yeah.
Thinking culturally speaking, like I think people, most of them were finding that it was shameful to have COVID.
Okay.
So they were not reporting data. So that big there, it could be they would do something good and then they reverse, or there were people that decided I don't want to say anything about it until they got things bad, and then that's like
Great. Yeah. So that's again, like we have context to the situation, right? And you're hinting at like a data caveat of, well, is this actually reflective of what's going on? Or perhaps, you know, we just like discovered that there are more cases. Did I see it? Yeah.
Your x-axis is inconsistent. Just in January and April, last like 14 months, like 2 months.
Yeah, that's a great point. I'm actually not sure why. Like this is just a screenshot from like the our world in data explorer. I personally am not sure how they space those ticks. Does not make sense to me. Yeah.
What if they just weren't testing prior to?
Yeah, that's a great point. It's so flat prior to like, yeah, September, November. It's kind of very surprising what was happening. Any other insights? Okay, so where I got this was from a similar tweet that linked this rise to the start of the vaccination program in Uruguay. And this is super interesting and like hits on like most of the things we've come up with, right? So we might not be like, I don't know, thinking about this or sharing this this thought in class, but we have like similar approaches to getting insights from the data, right? You like inject your personal knowledge and context into maybe what was going on in the area. You kind of think about like, oh, well, this doesn't look right, or like there's so few cases, perhaps they weren't testing enough. Well, someone looked at this chart and was like, there were so few cases because we didn't vaccinate, and then we started vaccinating, there were many cases, so duh. So this is all kind of examples to show you that design choices, even if you follow all the guidelines of rule books, they do shape our insights. So when you create a chart, oftentimes you will have like a major salient feature in this chart, right? Like a huge increase, a huge drop of like a value because of because the underlying data shows that, or because your choice of encoding underlies that, you should be mindful of that. Not always can you offer an explanation to something, but you kind of should be mindful of the fact that it existing in the chart will cause people to, the gears will start grinding, the explanations the hypotheses will regenerate it. The framing of these visualizations, like to many, it wasn't immediately obvious, like from this chart that we were talking about vaccinations, but here they added text, they added annotations, they embedded so much meaning into this chart that I would argue for most of us not exist here. And like, it's a design choice. Like in many cases, it will be completely appropriate and correct to embed a lot of expert knowledge to explain phenomenon that we observe in the chart. And we talked about context, like some things you just generally know from world knowledge, some things you know because it's like personally relevant to you, or you're an expert in a given area. So like two people don't look at the same chart the same way many times. You have your own personal biases. Like, for example, if you see a chart that proves the effectiveness of vaccines and you do believe that yourself as well, like you would probably not look for kind of design issues with it in a way, right? It like affirms your belief, you let it go, and vice versa. This is all tied into this distinction between a chart that's neutral versus directive, a chart that is a narrative or like an exploratory visualization, right? This would be like a very neutral chart. This would be a chart that is directing you to think a certain thing. These are all kind of design choices that I would argue for general audiences, it is so much more important to have a directive for the viewer, just because you can be, aside from like being misled, you can just be lost in a chart if you don't really know what to look at. There's this blog post entitled "The Biggest Misconception in Data Visualization," which is super interesting. There's a link in the slide. To kind of reinforce this idea, there's no one best way to visualize data, right? So given the table, the data set in the top left, we have three charts that are, I would argue, perfectly fine charts. You can find some things that are maybe not great about them, but like they don't really violate any like design guidelines or anything. But they simply just answer very different questions, right? So we only have 10 data points, but if we visualize them in graph A, well, it would be perfect if like your boss was asking you for a chart and had a question of like, oh, what region has the highest expenses? What region has the highest budget, right? It's very easy to answer this question. But it would not be the best chart if your boss asked you, well, which region has like the largest deviation from the original budget? It's kind of hard to compare, right? The line segment, which shows the budget, versus the bar height, which shows the expense, but it's super obvious from graph B that that is the best chart for the job. If the job was to show which region kind of contributed the most to the general budget deficit, chart C would be your best chart. So, like charts never show the data, they always just show a few specific insights from the data. And as a visualization designer, picking your encoding, picking so many different things, the scales, is your way of expressing what insight should be. Yeah.
Something else I noticed, it might be the color choices, like red, most people implies danger, green is good. And the color choices here to me tells me the other way around, right? Looking at the color, we see like, oh, the Saudi is spending the less, it's actually the other way around, they're all.
Yeah.
Color choices there to kind of a quick glance and tell you one picture.
Yeah, so you highlight a very important design choice in this chart that was happening, which is kind of not entirely, maybe this is not the best way of doing it, but I think there is like a tension of they were looking at deviations from budget, which they calculate as like expenses minus budgets, like how much you went over the budget, and like higher is more, less, lower is less, but higher is bad and lower is good. So that's, I think that's why the color choices, like the higher the bar, the more they exceeded their budget.
Oh, I see. Okay.
Yeah.
See, the color
Yeah.
choices, yeah.
Right, but it does go up, which kind of could be seen as good. So there's just also this like interesting tension. Yeah, so the point of this blog post was that there's no best way to visualize data. We really wish there was. And they showed this chart of like, well, what if you wanted to show everything? Well, what if you want to answer every question? Well, then you end up with what they call a spaghetti chart of you can probably read everything off, but it's just a lot. It, in a way, doesn't answer any individual question better than the previous charts. It also still doesn't answer every question. Like you can imagine someone wanting to know, I don't even know, but I'm sure there's a question that this chart doesn't answer either. And also a relevant Twitter thread on design considerations, also linked in the bottom of this slide, was by Colin Angus, who's I believe he's a researcher at Sheffield University, specializing in like alcohol policy. So he had like this pretty long and interesting thread on his design choices of one given visualization that he designed. And I would totally recommend everyone look at it, because he like talks through almost like every design choice that went into this chart, right? Why is it a bar? Why are the colors the way they are? Why is he like faceting by country and then having age on this axis and the other thing on the other axis, and why he sorts blue over red and not the other way around. Kind of one, so everyone should read this, but one thought I wanted to highlight was he was talking about why he chose to title the chart "Scotland has a drug problem" instead of alcohol and drug use in the UK. So he had this idea that like people will always find their own messages and graphs, which I think we've shown, but why not help find them the right one? And right here, quote unquote, obviously it'll be like biased by who is designing this and who thinks what right and wrong is. But I think the idea still stands that people can be confused, people can be misled. So I think it's important when designing a visualization to like guide the people in a place you want them to be. And hopefully you've done your background research to kind of know that this is the right place. So going back to one chart that we've looked at is, see, if we wanted to help people find the right message, but also steer them away from the wrong one. So this is a chart from a CDC report, and very roughly the kind of like the message of the report could be distilled to: vaccines do provide protection to people from COVID, but kind of don't let your guard down. There's the Delta variant coming up. There were some 4th of July gatherings, and there's this like big crisis. So I'd argue it does kind of steer you in the direction of, you know, COVID is a problem. It doesn't necessarily steer you away from the thought of like, hey, vaccinated people are like super spreaders. But without changing the chart too much, I would argue that you could still embed sort of enough information to this to steer people away from quote unquote wrong conclusions. And one thought was like, I think your conclusion was that people are highly vaccinated in that country. This is actually in that county. This is actually super true. There is no data on kind of the vaccination coverage of everyone who's attended the gatherings, but the main gatherings were in Provincetown, Massachusetts, and their vaccination rate was at the time over 95% in most age groups. So what if we just showed that, right? I'd argue this information in the chart would kind of hint at this idea and maybe steer some people away from this conclusion that vaccinated people are disproportionately getting COVID. And this is it. We are a bit early, but I don't really have anything else. So We'll see you all on Thursday. Yes, I think Alex will be back.